All right, section 1.7, this is our last section that we're going to cover in chapter 9. We are going to skip 8 and 9 because really those are going to be covered in chapter 2. So 1.7, we're going to be talking about the distributive property, and this section is really setting us up for the rest of algebra. So this section, I'm going to put it on one of the most important sections that we have in chapter 1. So we have 4 vocabulary words I want to talk about. The first one is term, and a term is the parts of an expression that are separated by a plus or minus sign. Okay, and you should have worked with terms last year. The next vocabulary word is a constant. A constant is going to be a term that does not have a variable. Third vocabulary word is coefficient. This is a numerical factor of a term. And then the last definition that I have is like terms. These are 2 or more terms that have the same variable raised to the same power. Okay. So I know that's 4 definitions, that's a lot. So I have a diagram for us that I want us to create that'll really help each of these definitions make more sense. So let's look at the equation 3x plus 4x minus 7 equals 5. Well, on the left-hand side, the 3x, 4x, and negative 7, those are each terms. Notice there's 3 terms, and they're separated by either a plus or minus sign. Okay. Then next, look at the 7 and the 5. There's not a variable attached to the 7 or 5, so those are called our constants. Okay. So if you look back at the definition, a term that does not have a variable, something to know, extremely important, that 7, it is not a positive 7, it is a negative 7. The sign in front of the number determines if that term is positive or negative. So that term is a negative 7. Okay. Next are coefficients. We only have 2 coefficients. We have 3 and 4. That's the numerical factor of a term. Okay. So sometimes you're just told the number in front of the variable. Those are our coefficients. And finally, like terms. We have 2 like terms, 3x and 4x. Okay? We can also say our constants are like terms, but they're in different signs of the equal sign, so they are like terms, but we're not going to worry about that quite yet. Okay? So let's just work with a little bit about combining like terms. So our first example, 8x squared plus 2x squared. Well, notice they have the same variable raised to the same power. The variable is x raised to a power of 2. So I can combine those by adding, since that's the sign I have addition. I can add 8 plus 2. I'm going to keep the x squared. I'm not going to add the exponents. They're going to stay the same. So if I take 8 plus 2, that is going to give me 10x squared. Another example, 5x minus 3 minus 3x plus 6y plus 4. I'm going to go ahead, I'm going to highlight, and it doesn't show up the best, but I'm going to highlight some like terms. So looking at those, oops, got ahead of me here. The first it's kind of like a gray highlight. I've highlighted over the 5x and the minus 3x. That is one set of like terms. And then I have 2 constants, the negative 3 and the 4. That's another set of like terms. If highlighting doesn't work best for you, sometimes you can underline, put a different shape around the types of like terms. And then underneath of that, what I did, just like the previous example, I took 5 minus 3, put that in the parenthesis, and then the variable part was just x. I kept my 6y. And we always like our constants last. We write those last in our expression. So that's why I put the 6y before. And then my 2 constant terms are negative 3 plus 4. So now if I just simplify, 5 minus 3 is 2. So that term is 2x plus 6y plus negative 3 plus 4 is 1. Okay? So that is combining like terms. It's as simplified as it can be. Okay? So let's talk about the distributive property. I know in section 4 we covered a lot of properties, and this is a property we did not cover because we weren't quite ready for it yet. So the distributive property is used to simplify expressions. When we use the distributive property, we're going to multiply a number and or a variable throughout the parentheses. Okay? So let's see what that means. You're going to see directions such as simplify the expression. And if you see parentheses, expect to use the distributive property because it's not completely simplified yet. Okay? So 4 times the parentheses inside x plus 5. When we use the distributive property, we're going to take that 4 and times it by everything inside the parentheses. So I like to draw lines. So 4 times x, and then I need to take 4 times 5. And then if I write that out, just as I said, 4x plus 4 times 5. Now I can simplify. This equals 4x plus 20. If at all, when you are using the distributive property and you've eliminated the parentheses, if there are like terms, you always need to combine like terms. That's part of simplifying an expression. If you have not combined all like terms, that expression is not simplified. So got another one. Parentheses 4b minus 1 times negative 6. So notice the number is behind the parentheses, so I need to distribute the negative 6 to both terms inside the other parentheses. There's a lot of parentheses in this problem. So again, I'm going to draw my lines. So then if I write that out, I need to write 4b times negative 6 minus 1 times negative 6. And then if I can simplify, 4b times negative 6 is negative 24b. And then negative 1 times negative 6. Again, the number in front of the sign in front of the number determines if it's positive or negative. And since it's a subtraction sign in front of that 1, it means it's a negative 1. So I'm going to use the same signs that produces a positive 6. Okay. Last example that I have for you, 2 times the parentheses 3x minus 5 plus 4x. I need to distribute the 2 to each term inside the parentheses, and this time I have 3 terms. So if I write this out, I have 2 times 3x minus 2 times 5 plus 2 times 4x. Now I can simplify what I have. So I'm going to have 6x minus 10 plus 8x. And notice I have like terms. I have the 6x and the 8x that are alike. So I can combine those by adding them. So 6 plus 8 times x minus 10. And my final answer then would be 14x minus 10. Okay? And that's all I have for the distributive property. This is, again, a really important section. If you've taken notes and you're like, oh, I'm still not quite sure about something, go ahead and re-watch this lesson again. And your notes are already down, so you can just listen and look and not worry about writing down what is on the screen.